Heart disease. It's one of the biggest, scariest health challenges on the entire planet. For decades, we've thrown everything we have at it. Medicines, surgeries, you name it. But what if one of our most powerful new weapons isn't a scalpel or a pill, but an algorithm? We're going to dive into how some brilliant researchers are using machine learning in a totally new way to predict heart disease before it even gets a chance to strike.
Okay, to really get a grip on why this matters, you have to start with this number. 17.9 million. That's how many people died from cardiovascular diseases in just 1 year, 2019. It's an absolutely mind-boggling figure, and it shows you this isn't just a problem, it's a full-blown global crisis. And to put that in perspective, that 17.9 million, that's 32% of all deaths worldwide. We're talking nearly a third of everyone. It's the single biggest cause of death, period. So you can see why being able to spot it early isn't just important, it's absolutely critical. Right, so the best way to fight this thing is to catch it early. But here's the catch. Our traditional tools, like angiography, can be really expensive, super invasive, and they even come with their own risks. This is exactly why there's this huge push for a better, safer, more reliable way to see what's coming. And a lot of people are looking to tech for the answer. And that's where machine learning comes in. These AI models have this incredible promise, right? They can sift through mountains of patient data, find these hidden patterns that no human could ever spot, and predict risk without a single invasive procedure. But, and this is a big but, these AIs have a major weakness. They are incredibly hungry for data. We're talking huge amounts of high-quality data. And this right here, this is the central challenge that's been holding back medical AI for years. It's the data dilemma. See, for an AI to be any good, it needs to learn from a massive and, really importantly, diverse set of examples. But in the world of healthcare, getting your hands on that kind of data is just, well, it's incredibly hard to do.
You know, for a long time, researchers were stuck training AI on these small, kind of uniform datasets, often with less than 5,000 records. And what do they get? Well, they got models that looked amazing in the lab, but just fell apart in the real world, because they'd never seen enough variety. So the new approach, what this research is all about, is building a super data set, mashing different sources together to get over 300,000 records. Now that is a much stronger foundation.
And look, don't just take my word for it. This is a huge, well-known problem. As the researchers themselves put it, this lack of data and diversity really limits how useful these AI models can be for different kinds of people. You know, they're basically trained in a bubble, and we desperately need to pop that bubble.
So how in the world do you solve a problem like data scarcity? Well, these researchers didn't just sit around and wait for the perfect dataset to fall from the sky. Nope, they got creative. They built their own massive dataset by piecing together what was already out there. Let's break down how they pulled it off. They basically followed this awesome 4-step recipe. First, they grabbed 2 huge, public, but very different datasets. One was from actual clinical exams, the other was from a simple telephone health survey. Second, they hunted for the 10 key health metrics they both shared. Things like age, BMI, whether someone smoked. Third, and this part is genius, they harmonized them. They made sure that what one dataset called a smoker meant the exact same thing in the other dataset. Finally, after a whole lot of cleaning, bam! They had one giant unified dataset with over 311,000 patient records. So they built the super dataset. Problem solved, right? Mission accomplished? Well, not quite. They immediately ran into another much trickier problem. In their massive dataset, the number of people without heart disease was way bigger than the number of people with it. And that kind of imbalance can totally mess up an AI model when it's trying to learn.
To fix this, they used this brilliant little technique called SMOT. That stands for Synthetic Minority Oversampling Technique. It's a really clever statistical trick that fixes this kind of imbalance, not by throwing away data from the big group, but by creating brand new, totally artificial data points for the small group.
Okay. The best way to think about SMOT is like this. Imagine you're training a security AI to spot a really rare type of intruder. If you only show it real footage, it might never really learn what to look for. So what do? You create thousands of realistic holograms of that intruder and show them to the AI over and over again. That's exactly what SMOT does. It creates these realistic, synthetic examples of heart disease patients to properly teach the model what it needs to find.
So they built this massive dataset, and then they balanced it perfectly. The stage was set. It was time for a showdown. They unleashed 10 different machine learning models on the data to see which one could become the new champion at predicting heart disease. Let's see what happened.
Okay, first, let's look at how the models did before they used SMOT. Now, you might glance at the accuracy scores and think, hey, that's not so bad. But that's a trap. The number that really matters here is recall. Recall tells you how good the model is at finding the people who actually have the disease. For this one model, CatBoost, its recall was just 0.44. That means it was completely missing more than half the people who were genuinely sick. In a real clinic, that's not just a bad score, that's downright dangerous.
Now check out the results after they applied SMOT. I mean, the difference is just wow. The recall score for that same CatBoost model shot up from a pathetic 0.44 all the way to over 0.92. Just by balancing the data, the model suddenly learned how to correctly identify over 92% of the actual heart disease cases. It went from failing its most important job to being top of the class. When the dust finally settled, 3 models were left standing at the top: CatBoost, Light GBM, and Gradient Boosting. I mean, it was an incredibly tight race between these powerhouse algorithms, but at the end of the day, CatBoost just edged out the others to become the champion. It had the best overall score for telling the difference between healthy and unhealthy patients.
And here's the winning number, 94.4%. This was CatBoost's AUC score. Now, the easiest way to think about AUC is as a measure of its overall diagnostic power. It basically means that if you gave the model 2 random people, one with heart disease and one without, it would have a 94.4% chance of telling you correctly which person was which. That is an amazing level of predictive ability.
So what's the big takeaway here? This is so much bigger than just one cool algorithm. This research gives us a powerful blueprint. It proves that we can build much more reliable AI for healthcare, not by waiting around for perfect data, but by cleverly combining the messy, real-world data we already have. A model like this could one day be built right into a doctor's system, acting like an early warning signal, a tool to help them make better decisions, and flag those high-risk patients who might have slipped through the crack.
And that leaves us with this final, really exciting thought. This whole approach, merging diverse data sets, balancing them with techniques like SMOT, it worked wonders for heart disease. So the real question becomes, what other seemingly unsolvable health problems are just waiting for a solution? A solution that might be found by creatively using the data that's already out there, waiting for us.